All right, guys, so for this one, we're going to determine the identification of substances by physical properties. And so here what we're going to do is we're going to do a solubility test. So as I'm going to show you real quick, this is what you should be seeing on your lab manual. And I'm going to get closer so you can see that you have, first we're going to do the solubility test, and then we're going to determine the density of the solid unknown and then determine the density of a liquid of an unknown. And so I have the test tubes here. So what we're going to be using is I have some liquids in here that I'm going to be pouring out. So I have my unknown liquid, as you can see, and then I have the unknown solid. Hopefully you can't guess what it is. And then we have toluene, and then here we have naphthalene. And then hopefully you can see that I try to write them bigger on the post-it so you know exactly where it is. And then here we have deionized water. Here we have cyclohexane, and here we have ethyl alcohol. And so what I'm gonna do is essentially I created, hopefully you can understand the matrix the way the idea is. So we're gonna use test tubes, and we're gonna fill this group of test tubes with deionized water, this group of test tubes right here with cyclohexane, and then my last column, we're gonna fill them in with ethyl alcohol. And we're gonna be using pipettes for our liquids, and here it is. And then of course I'm gonna be scooping it in. So here we have the test tubes, and like you said, hopefully you can notice that here we're gonna fill all these, all this row of test tubes with naphthalene. And then here we're gonna fill the second row with toluene, and then of course the third row with the unknown solid, and then lastly the unknown liquid with the last row. And we're going to determine the solubility idea. And if you don't know how solubility works right so far, all it is pretty much if their polarities are in tune, the type of intermolecular forces that are at hand. And usually we determine this idea of like dissolves like. And so if they're similar in polarity or identification through intermolecular forces, then we would consider them to be soluble within it. So for instance, if it's a polar solvent, then anything polar or ionic will dissolve in that polar solvent. But also with a nonpolar solvent, if we consider it to be a nonpolar solvent, then any kind of nonpolar solute will be dissolving in that nonpolar. But of course, nonpolar and polar, if you try to mix the two, they will tend to separate. Okay, so let's go ahead and get started. So I'm gonna drop a little bit of the ethyl alcohol first into its beaker. I don't want to directly, as you can see, I don't want to directly get a little bit. I don't want to directly pipette out of the stock solution. I want to reduce contamination as much as possible. So you never want to directly pipette out of the stock bottle. So then I'm going to get the cyclohexane. I'm going to open it up. And so here we have, don't want to abuse. If I need some more, I'll go back and get some more. And then so that's my cyclohexane. The water I'm not even going to mess with. Then I'm going to get some naphthalene. These are mothballs. So if you haven't cleaned out a closet or a drawer in a while, that's exactly what it's going to smell like. Whew. Smelly. Wow. It smells, some people say it smells like old people. I think that's kind of messed up. Yeah. I hope old people shower too, right? I hope so. Because I'm pretty old and I shower. So I'm going to be a little delicate here with the toluene. Oy. Oh, no goodness. Oh, we got a little spill going on. Okay. Go ahead and clean clean that up real quick. Get a paper towel over here. All right. Okay. No. Okay. Throw it away right now in our contaminated pile. Can't guess what an unknown solid is. And then our unknown liquid. Ooh, man, that is smelly. All right, so based on physical properties, we're gonna see if we can determine what our unknowns are, okay? And so the first thing that I'm gonna do is I'm gonna fill up all my pipettes I'm gonna fill all my test tubes with the solvent. So in this case, the solvent's gonna be water for this one, for this whole row. All right, let me just fix the camera real quick. So I'm gonna get some more water. I'm gonna fill it up with a bit. Let's try to be as... So this is a qualitative analysis. This analysis is just based on observations. We're not gonna record any measurements. And so we're just gonna determine whether it dissolves in that solvent per se. So we got our water going on. And so now I'm gonna add my cyclohexane to all of my middle test tubes. That'll be the solvent. So we got a few here. Okay, so we got one. Let's get the second one. All right. Got the third one. And then let's see, let's get the last one. Let's see how much we have of it. Okay, so that's my cyclohexane. It's a little bit more. Okay, so that'll be the solvent for that one. Let's get the ethyl alcohol going. Okay, got one. Got two. I need some more on that one. So again, I'm gonna get some more ethyl alcohol or ethanol. Make sure that after you use every single chemical, make sure you close it. Want to prevent a potential accident. Okay, and lastly, the last one. All right, and so now I've gotten all my solvents down. Remember that this idea is gonna be all, I'm gonna switch it over here, right? And I'm gonna tell you that all these test tubes, the solvents are gonna be water. And then here, all my solvents are gonna be cyclohexane. And then here, all my solvents are gonna be ethyl alcohol. And so I'm gonna just zoom in a little bit, hopefully y'all can see. And so then what I'm gonna do now is I'm gonna add first naphthalene to all my first row, okay? And I'm gonna create a matrix so that we can determine later what happens to determine whether it's soluble. So now I'm gonna get a little bit of some flakes of naphthalene. And then as I get a little bit of flakes, you don't need that much. We're gonna drop it into the water one. Okay. And then we'll record some observations. Get some naphthalene and we're gonna put it in cyclohexane. Right. It got stuck on the side of on the walls of the test tube. Or a little bit, whoops. I'm gonna add some to the ethyl alcohol. It's got stuck on the side of the container too. Oh, come on. Almost, there we go, we got them on. Okay, so we're gonna return these, the naphthalene pile. Now the second column, right? We're gonna add some toluene. So I'm gonna add some toluene to water. Now remember that we have to add enough so that we can see if it dissolves into the solution. You also don't want to stick your pipette into the beaker test tube completely because then you might run into, again, contamination. So we're adding to the cyclohexane. So we're adding toluene to our cyclohexane now. And like I said, I'm gonna add enough so that if there is a separation, we can see it. And then again, we get the test tube for ethyl alcohol. Now my solvent is ethyl alcohol. I'm gonna put in some toluene, I'm sorry, as a solute. All right, that should be enough. Whoops. All right. And so that's that one. And now my third. Now I'm gonna add my solid unknown into water. Okay. Add a little bit more water so I can flush down the side of the container. Okay. Then I'm gonna add some salt here. Whoops. I'm gonna add some salt to my third one, which is a cyclohexane. Same thing with the ethyl alcohol. Okay, and if we need to, we'll add some more too. And then lastly, we're gonna add our unknown to our last column. So based on these properties, your job today will be to determine what the unknown solid is and what the unknown liquid is. All right. Okay, So now we're going to check our observations, and so we're going to determine whether it's soluble or not based on what you see on the test tube. So first, we're going to have naphthalene and water. I'm going to shake a little bit, see if it dissolves. Okay, and it seems not to be, right? And we're going to check right now back in 15 minutes, okay, to see if it actually dissolves or not. Here for cyclohexane, we're going to shake it a little bit. And I believe it is dissolving here. There are a little bit of flakes at the base. Very small amount. Can't even see them. Yep, there you go. It did dissolve. There's nothing there in there that I can see besides that black spot or brown spot, which is on the outside of the container. So there you go. Naphthalene did dissolve in cyclohexane. And then here we have ethyl alcohol. We're going to shake it a little bit. And as you can see, this one is very similar to water. It's not dissolving. Okay, so let's now check out our toluene, which is our second row. Toluene and water. If you notice, there is a separation. Can you see the separation? There's a clear division between the two liquids. Now, we put more water in there, so we assume that the bottom layer right here is going to be the water part, and the top layer right here. Hopefully, let me zoom it in some more. Just give me a second. Gotta check out my camera here. All right, we can see the two layers there. The top layer is gonna be your toluene. That was a less amount that we put. So what this is indicating here is that based on our density, since these don't mix at all whatsoever, right? Even if we shake them, right? Okay, so for the next part, what we're gonna do is we're gonna determine the density of this unknown liquid, right? So whatever, what we're gonna do is first we're gonna measure out a specific volume, kind of how we did it in the last lab. What we're gonna do is we're gonna record a specific amount of volume that I'm gonna take out. But before we do that, let's go ahead and measure our graduated cylinder, okay? And as you can see, the mass of the graduated cylinder is going to be 33.43. Let's go ahead and see if we can center it a little bit better. See if that changes. No, 33.43. Then we're going to go ahead and zero it out. And so once we zero it out, now we're good to go. We're now going to take out some of that liquid. And we're going to measure about, we can go ahead and see, let's go ahead and measure out 5 milliliters, see if we have enough. Okay. And then, I think we might only have enough for 4. So we'll go ahead and just do 4. All right, so trying to connect here. So based on what we saw on our solubilities, cyclohexane right here was one of the solvents that did not dissolve the white solid that we have. So what I'm going to try to do here is, hopefully you all can see. I'm going to fix it. So what we're going to do now is we're going to determine the density. Let's double check if I'm recording. Alright, so we're just going to double check the density. Sorry. Put it back on my head here. We're going to double check. Well, we're going to do the density. We're going to base it off the solubility of cyclohexane. So first we're going to record a volume of cyclohexane. We're going to keep it simple. What? I'm not going to pipe it directly out. Got a certain amount, not too much. Once we get the cyclohexane, here I have a graduated cylinder. And we're going to measure out about, I'm going to say at least 5, no, let's go with 3. And so the reason why we're using cyclohexane as a solvent for the unknown solid, it's because it's not readily soluble in it. So we'll just use, okay. So here we're gonna put the cyclohexane. I'm gonna take off the camera so hopefully I can zoom in visibly so you all can see. I'm trying to put it as eye level as possible. And let's see if I can zoom it in. And as you can see, it is about, my eyes are right next to it, so it's about 3 mils that we're gonna do. So let me zoom out now. All right, so now we're gonna use a beaker, and as we use the beaker, okay, so now we're gonna place the beaker on top, and then now we're gonna get, since we already know that we have 3 milliliters on there, well, it's too heavy. Well, hopefully it's not too much. Let's go to this one over here. So, let's see, it's 210 grams max. And so we'll put this on there. Let's see if it goes to max. No, we're good. And so what we'll do is we'll zero it out. Whoops. We'll zero it out so that it takes it all entirely, right? And then the next thing that we're gonna do is we're just gonna add our salt. And so let's go ahead. So we know we have about 3 milliliters. So now we gotta determine how much salt we're gonna use. And we're gonna take out the amount. And so as we get the solid, we're gonna see if we can try to get it in as much as possible. And then right now we'll determine how much volume it goes up. Not a good chunk. Now if it spills on the side, don't, it's not really, so now, can't lose any of the liquid. Okay, so now, okay, we'll see how much mass we've put in so far. So we've put in, as you can see, 1.2 grams of the salt. 1.19 grams of the salt we've put in. And so as we take it out, let's see how much volume we have displaced. And as you can see, we have displaced, where are you? Right about, we're at eye level, I want to say we're at about 3.35. Okay, as you can see, let's see if I can get you at eye level. Yeah, we're at about 3.35 milliliters as our final volume. Okay, and so that'll provide you with the density. So again, the mass of salt that we have used did it go down or is it evaporating or what the hell? We'll go with 1.13 grams. And then we said 3.35 as our final volume. Our initial volume was 3 milliliters. Okay.